In section 3.4, excuse me, we're going to now work on solving a system of equations that has 3 variables and 3 unknowns. And so what I want you to do is I've given you these steps, but I want to break it down into an even easier way. What you're going to really want to do is you want to choose a variable to eliminate. Choose a variable to eliminate, and then what you do is you combine 2 equations to eliminate that variable. And what it does for you is this creates a system of 2 equations, and then you just solve that. So what you're going to do with 3 equations with 3 unknowns, you're going to pick a variable to get rid of, x, y, or z. And you get rid of it by combining 2 equations at a time. Then this is going to result in a system of 2 equations, and we just practiced with our warm-up today with our farm animals, our pigs and our ducks. We figured that out. Now what can happen though is if at any point in the body of your work you get a false statement like 0 equals 1 or 0 equals 8, it's no solution. If you get 0 equals 0 or 3 equals 3, there's infinitely many solutions. And we're going to see both of those cases a little later. Alright, so let's look at example 1. Now what I need you to do, because there's a lot of work involved on this type of problem, I need you to put a bubble 1, a bubble 2, a bubble 3 next to each equation. And what you're going to do when you want to choose your variable, you want to scan through and see if you see a variable with a 1 or a negative 1 in front. So do you guys see? You see a negative 1 in front of the y. So we're going to eliminate y. And here's what we're going to do. We're going to take, and you have to do this for me, guys. You have to write out what you're doing. And I'll tell you, I guess you can opt not to do it, but then I'm not going to look at your work. If you're not going to tell me what you're doing, I'm not going to play detective, and it'll be, if you got it wrong, it's wrong. That's it. I love to give partial credit, but I cannot go and have to try to figure out what you were doing, because this is pretty complicated. So watch what I'm going to do. I'm going to take equation 1, and if I want to get rid of y, what do I have to multiply the third equation by that would eliminate the y? A 2. So watch what we're going to do. We're going to take, and I just need you to write this very simple thing down, and then you do as much work as you like from there. I want to give you partial credit, but I have to understand what you're doing. And you'll understand better as we continue. But I'm going to take equation 1 plus 2 times equation 3, and that will get rid of the y. So let's write that down. Here's equation 1. And then I'm going to multiply equation 3 by a 2. So that results in 12x minus 2y plus 8z equals negative 2. Let me give you some advice, because I've taught this a very long time. The most common mistake I see is students forget to multiply the right side, that number, by that number. So be careful. If you get a problem wrong, go check that first. Alright, now we're going to add the 2 equations together, and I get 16x plus 11z equals negative 1. And I want you to put a box around it, because as we move through these, you're going to understand better. So just trust me for now. Let's put a box around it. Now, we need to get rid of y, but we can't combine equation 1 and 3. You need to do 2 with 3. So I'm going to take equation 2, and then what would you have to multiply equation 3 by? That would make it the opposite. A minus 3, right? So I'm going to take 2 and add it to negative 3 times the third equation. And it would be perfectly fine to put minus 3 times radical 3, but we are adding them together. 2x minus 3y plus 5z equals negative 14. And then I'm going to multiply the third equation by negative 3. So I get negative 18x plus 3y minus 12z equals a positive 3. So again, we're taking the second equation and we're adding a negative 3 times the third equation because we're trying to get rid of y. And let me point this out just in case somebody would happen to do this. When you choose your variable that we chose to get rid of y, you have to get rid of y out of both sets. Okay, you don't do y on one and x on the other because then you're stuck. So if I add these together, I get negative 16x minus 7z equals negative 11. And put a box around it. Now what I've done is, remember on the first screen, we said you pick a variable to get rid of, which we did. This creates two equations with two unknowns, and these are the equations in the box. So we're going to line those up together, and the good news is we know how to solve a system of equations. We just spent 2 sections, graphing, elimination, and substitution. So I add these together and I get 4z equals negative 12. Divide by 4, z is negative 3. Now we're going to do a technique called back substitution. In this previous equation, the 16x plus 11z equals negative 1, I could plug z in and find x. So that's what I'm going to do. I take 16x plus 11 times negative 3. And so I'm back substituting. So I get 16x minus 33 equals negative 1. Add 33 to both sides, and I get 16x equals 32. Divide by 16 and x is 2. Now how do you think I can find y? Plug it into one of these first equations, okay, where there's a y. So it doesn't matter which one you do. I'm going to pick the first one. 4 times 2 plus 2y plus 3 times negative 3 equals 1. So we get 8 plus 2y minus 9 equals 1. I get 2y minus 1 equals 1. Add 1 to both sides. 2y equals 2, so y is 1. If you remember to that previous section that we did graph solving a system by graphing, substitution, elimination, how did we always write our answer? An ordered pair, right? X comma y. Well, that's exactly what we're going to do here. They're going to be x comma y comma z. So this is 2 comma 1 comma negative 3. Okay? All right, let's do another one. And you don't have to pick the one that has a 1 in front of it, but it is awfully convenient to do it that way. We could get rid of x, we can get rid of z, whatever you choose is okay. And that's where it gets very, very confusing because there's so many different ways to do it. So anybody want to give us a suggestion? What could we do? Henry? Okay, so the top one, and then we're going to get rid of y. So then what are we going to do if we want to combine that with 2?
Good morning. Can I have salt?
Ready, go. All right, so I would take, 4 times the first one plus the second one. Would that do the job? So this will be 8x minus 4y plus 24z equals negative 16. And I line it up with the second one. So what I'm saying to you is put this bubble stuff, 4 times 1 plus 2, if you would like me to give partial credit. If you do not want, if you get it wrong and you wish to receive 0 points, that's your option. You can do that. So I'm going to add these together and put a box around it. So now I hope you can understand the reason why we want to put a box around it is there's so much work, so much going on. That's our first equation for 2 unknowns. All right, so now I'm trying to get rid of y. What can I do now? I cannot combine equation 1 and 2. I've got to do 1 with 3, but how, what do I do? If I multiply by 2, that doesn't do it. Negative 2, right? Okay, so negative 2 times the first one plus the third one. Does everybody see that? It takes a little bit of getting the hang of it, but I'm trying to make the y up here be a positive 2y. So this is negative 4x plus 2y minus 12z equals 8. So I multiplied everything by a negative 2, and then I'm going to line it up with the third equation, and then add them. So I get negative 8x minus 7z equals 17. So let me put those two together. 14x plus 19z equals negative 23. Oh, yuck. So which variable we want to get rid of? You can either multiply the top one by 7 and the bottom by 19. We might need our calculators. I'm thinking, doesn't 14 go into 56 4 times? I think it does. Yeah, so let's multiply the top one by a 4 and the bottom one by a 7. And let's try and do it without the calculator, okay? So this is going to be 56x plus 4 times 19. 4 times 9 is 36, carry the 3. 4 plus 3 is 7. 23 times 4. 4 times 3 is 12, carry the 1. So that's a negative 92. 17 times 7. 7 times 7 is 49, carry the 1. So I'm adding those and I'm getting 27z equals 27. Oh, that worked out nicely, didn't it? So z is 1. Now let's back substitute. So I'm going to take that equation 14x plus 19z, so that would just be 19, equals negative 23. Subtract 19. Are you guys getting x equals negative 3? Yeah. And then we're going to plug it into any of these first equations. So let's take 2 times negative 3 minus y plus 6 times 1 equals negative 4. Wasn't that nice? Negative 6 plus 6 cancels. Divide by negative 1 and y is 4. So our final answer would be negative 3, 4, 1. So let me recap. It's a lot of work, okay, a lot of work. but you're going to pick a variable to get rid of. And you take two equations at a time and get rid of that variable. Then it creates a system of equations, and then we know how to proceed. Okay? Alright, now we need to get to our special cases. So I do need to speed up just a little bit for time. Do you see that if I take equation 1 plus equation 3, that's going to eliminate the y right away? So this is 4x plus 3z equals 8. I'm going to put a box around it. Then I'm going to take the second equation plus 4 times the third equation, and then that'll get rid of y for me. So the second equation is 4x plus 4y plus 4z equals 7. And then I'm going to multiply the third equation by 4. So that creates 12x minus 4y plus 8z equals 20. Add those together. Then put those two equations together. And then it really doesn't matter which variable you try to get rid of. I'm going to go ahead and multiply the top equation by -4. That creates an equation negative 16x minus 12z equals -32. Line that up with the second equation, and I get 0 equals -5. I have a false statement, so it's no solution. Any questions? Does it make sense? It's complicated, but it makes sense, right? Okay. Alright, let's try and get the last one in here. Alright, suggestions. What should we do here, Carmel?
We should eliminate z.
Awesome. Let's eliminate z. So if you add equation 1 plus 2, now let me make a suggestion here. If you're getting the hang of this and it is something straightforward like 1 plus 2, watch what I can do. Can't I just add them? Because the z's cancel. Like if it is just one equation plus the other, I wouldn't recommend this when you're taking equation 1 plus 3 times equation 2. But if it's a straight addition, I think we could do it. So then we're going to do equation 2 plus 3, and I'm going to get 4x plus 4y equals 16. Do you see how I did that? If it's just a straight addition to two equations, you can just do it mentally. So, excuse me, there's my system. So let's multiply the top one by a -2. I get -4x minus 4y equals -16. I line it up with the second equation, and we get 0 equals 0. That is a true statement. Which means there's infinitely many solutions. No. Good question. There's no